that can produce a lot of energy. Why we would call this kind of different to a battery is that you actually can make a consistent power supply that doesn't run out like a battery does, as long as you have a constant supply of your fuels. Obviously within a battery, if we go back to one we had before, if I can find it, which I can't. Essentially, once your chemicals inside run out, you're kind of stuck. Like, unless you recharge it, that's all you've got. With this, you can actually have a constant supply of those chemicals. The basic idea, now this wouldn't be on your exam, it's basically a rectangle with a kind of dividing separator, a bit like a salt bridge in between. You've got 2 platinum electrodes connecting up to a power supply, so I put a bulb in there, but obviously it'll be like a battery or something. Your 2 fuels are being supplied constantly, so that's hydrogen gas and oxygen gas being supplied consistently, and then any water that's produced at the end can sort of come out the other side there. So you're constantly putting in your 2 fuels that's constantly powering this reaction to get the cell to the electrons to flow, and then your byproduct, your water, will come out the other end. So that is a constant way of making electricity. One wee thing just to finish off, there's a couple maybe cell representations you could put in. Now, for some of them I think they're a bit too complicated, but maybe these last 2 you could be asked for conventional or like shorthand representations. Just going to give them to you now just to talk through them. If we look at this one here for the lithium ion cell, that's secondary battery, your half equation look kind of a little bit lopsided. The left hand side is very simple. Remember, oxidation on the left. Lithium is just being oxidized to lithium plus. On the right hand side, the oxidation products are this lithium and this cobalt oxide. So your right hand side will look like this. They're kind of in one phase together because they're going to make a compound together. The reduced form of that is obviously the compound. So that's the 2 kind of raw materials making your compound once that cobalt oxide is reduced. Remember, it's showing oxidation towards the middle, so in that sense. And that will actually involve a platinum electrode just to get those 2 to come together. So a little bit complicated, but it does match up with what you've got in your equations. Last but not least, your representation for your fuel cell. Again, you will actually need platinum electrodes because these are 2 gases coming together. So it ends up being quite a long looking representation. Platinum on the outside. On the left hand side, your oxidation electrode is your hydrogen one. So hydrogen in a different state to your hydroxides, because that's actually needed for the reaction to come together. The hydroxide, however, is in the same phase as the water with a salt bridge, because the water is what's going into the reduced form. Oxygen on the right hand side, water again in the same phase of hydroxide with platinum on the right hand side there. So that's how we'd represent the conventional cell notation for the fuel cell. So that's a rundown of those 5 types of cell or batteries. If something like that didn't make sense, send me an email or send a comment below the video. Otherwise, have a look at the past paper questions that I've uploaded, and any problems with them, again, let us know, girls. Okay?